Okay. All right. So okay. So I want to show that Tor. So here's one of our goals. Tor IAB is the left-derived functor of A like this of B, and it's also equal to the left-derived functor here B, and then we apply this to A. Okay, so this is one of the things. So if A and B are R modules, one of the big goals that we have is we want to show that that taking a resolution of A and then tensoring it up to B is the same thing as taking a resolution of B and then tensoring it up to A. Let's say so. Okay, so we want to show that those two processes are the same. Okay, and so we need to. I need to introduce some kind of terminology here. I didn't know a good place to put this. And then after I set everything up, then I'm going to give the definitions. So let's give some definitions. So first, one. So a complex A bullet is acyclic if and only if HI A is equal to 0 for all I. Okay, and so I'm omitting the bullet here. Maybe I could put the bullet there if we want. I'm going to start omitting the bullets more. Okay, so a morphism of complexes so a chain map is a quasi-isomorphism. There's a quasi-isomorphism if and only if. So let's take a. We need to take a. So let's write down the morphism F bullet from A bullet to B bullet. If and only if the induced map, if and only for each I, HI of F from HI of A to HI of B is an isomorphism for all I. Okay. So this is what these are two notions that I'm just going to use. So acyclic means that it's zero homology, and quasi-isomorphism means it's a morphism of chain complexes is a quasi-isomorphism if and only if this is an isomorphism. As a warning, sometimes there's going to be more quasi-isomorphisms later. If sometimes, so there's a thing called derived categories, and you add kind of extra quasi-isomorphisms. But for now, we're just going to talk about morphisms, chain maps. When are they quasi-isomorphisms? Okay, so so let's do an example. Right. So if A, so I had talked about this before, but now I've made it explicit. So A is an R module. Okay, and we view it as a complex in degree 0. Then and we take a projective resolution or any resolution, and P to A is a resolution then it is a quasi-isomorphism. I mean, by definition, almost. Okay, so yeah, I mean it is. So what we're having here is we're saying that we have P0, P1, P2 like this. We have A like this, and then this keeps going. And all we're saying is that this is a quasi-isomorphism of complexes. So this complex has zeros everywhere. These are the zero maps everywhere. Okay, zero like this. Okay, and so this thing is a quasi-isomorphism of complexes. And that's because H0 P, this is isomorphic to A, because if you were just kind of like, if you're just going to take this sequence and move it out, then that would be an exact sequence. And so this map would be, the map from P0 to A would be a surjection, and the kernel would be the image of P1. And that's what this is. So this is the kernel of this map is P0, and the image is the image of P1. Okay, and that's what computes the zeroth homology. Okay, so so what's an example of an acyclic complex? So any exact sequence, not necessarily short exact, but any exact sequence is acyclic. Gives an acyclic complex. Okay. All right, so I want to talk about shifting operators. So I need to talk about shifting